Welcome to our deep dive into artificial intelligence, audit outputs and reports. In this session, we are going to explore exactly how to document our findings, how to structure advisory engagements, and how to present complex data visually. Before we jump into the details, let us talk about the real-world utility of this knowledge. Mastering the art of the audit report is what separates an average auditor from a trusted strategic advisor. You will use these exact reporting structures to translate deeply technical algorithmic risks into clear, actionable business intelligence for your board of directors. This allows executive leadership to make immediate funding, operational, or safety decisions without needing a degree in computer science. Let us break down the anatomy of an artificial intelligence audit report. While it shares the same foundational skeleton as a traditional audit report, the artificial intelligence version requires significantly more depth in specific technical areas. The document always begins with the executive summary. Think of this as the 30-second elevator pitch for the entire audit. It distills everything down to the absolute essentials, providing a summarization of key findings and required action items. It also clearly states the final audit conclusion, the auditor's professional opinion, and the overall risk rating for the audited environment. Following the summary, we define the scope and objectives. In plain English, scope is simply drawing a boundary line around what we are inspecting and what we are ignoring. For an artificial intelligence audit, this boundary must explicitly outline several items. We must list the specific systems and individual machine learning models included in the review. We also document the exact data sets, examine the business processes involved, and the internal controls tested. Finally, the scope must detail accountabilities, meaning we clarify exactly which human beings or departments are responsible for these systems. Next, we outline our methodology and objectives, which is the detailed explanation of how we actually tested the system. This is a massive section with several critical pillars. First is data management. Before a model can make decisions, it needs data. We test the quality and integrity of this data, ensuring it is accurate and uncorrupted alongside rigorous checks on data privacy. Imagine auditing a municipal water supply. Testing data management is like inspecting the purity of the water source before it ever enters the city plumbing system. Second is model performance testing. We must report on specific performance measures to prove the system works as intended. A key metric you must know is the F1 score. To explain the F1 score simply, it is a mathematical balance between precision and robustness. For example, if you build a security robot, you want it to catch every single trespasser without accidentally tackling the employees. The F1 score measures how well the model achieves that perfect balance without leaning too heavily in one direction. Alongside performance, this section details our testing for bias and fairness, ensuring the model does not discriminate. It also covers transparency and explainability, meaning we check if humans can actually understand how the computer reached its decision. Finally, we detail the security testing performed against the model to ensure it cannot be hacked or manipulated. The third pillar of methodology is technology and process testing. This evaluates the factory assembly line used to build and maintain the software. We review the entire system development lifecycle. This includes change management to see how updates are approved, configuration management to ensure settings are secure, and release management to verify how new versions are pushed to live users safely. The final methodology pillars cover ethical testing outcomes and regulatory adherence. We must verify that the system complies with internal enterprise policies as well as external legal obligations. After methodology, the report moves into detailed findings. Here, every discovered issue is directly linked back to our initial risk and control assessments. We provide recommended action items with strict timelines for fixing the problems. Crucially, these recommendations must factor in operational practicalities and financial considerations. You cannot recommend a $10 million fix for a $10,000 problem. This section also includes the official responses from the management team members who own the flawed processes, acknowledging the issues. Finally, the report concludes with the appendices. This is where we dump the highly complex statistical charts, code snippets, and raw technical data. It keeps the main report readable for executives while preserving the deep math for engineers who need to verify our work. Now let us shift to a different type of output known as an advisory report. Sometimes the internal audit department acts as an internal consultancy. While some find this controversial due to potential conflicts of interest, it is becoming incredibly necessary. Why is this so valuable? Internal auditors offer an external but inside critical voice. The chief audit executive typically bypasses the normal management chain and reports directly to the board of directors or the audit committee. However, unlike outside consulting firms, your internal auditors intimately know the company culture, the proprietary technology, and the people involved. Because artificial intelligence governance is so new and requires collaboration across almost every department, having auditors consult during the design phase can prevent massive disasters before they are built. It also helps the auditors learn about the new technology firsthand, which dramatically improves future audits and builds strong collaborative relationships. When issuing an advisory report, you must carefully manage expectations. First, the scope of the advisory work must be formalised, documented, and agreed upon upfront. Everyone must understand that an advisory engagement is not a formal audit. You must define exactly who will receive the final report, establish a clear timeline for deliverables, and set up designated communication channels. Second, we must consider the risk boundary. As an auditor, acting as a consultant, you can provide advice on managing risks. You can even guide the team through the process of fixing problems. However, there is a strict red line you cannot cross. You absolutely cannot design the organization's controls, and you cannot take ownership of a process. To use an analogy, a driving instructor can advise you on how to steer out of a skid to avoid a crash. But the instructor cannot grab the wheel and drive the car for you. If they drive the car, they can no longer objectively grade your driving test later. Finally, let us discuss how we present all this complex information visually. Charts and visualizations are critical tools. They should be used directly in the report to highlight major insights, or grouped in the appendices and referenced in the main text. Dashboards are particularly vital for audit stakeholders and board members. Executives are busy, and they often rely on visual dashboards to instantly grasp the health of an artificial intelligence project without reading 50 pages of text. Whether these dashboards are generated by traditional data analytics software or by autonomous artificial intelligence agents, their use is going to explode across all areas of the audit profession. A staple of these dashboards is the heat map. A heat map is exactly what it sounds like. It is a visual grid that uses colors, like a weather map, to show where risk is concentrated. Red means high danger, green means safe. When designing a heat map, the data should flow directly from your standard audit methodology ratings. Alternatively, it can be generated using the broader enterprise risk management framework already understood by the business. This ensures that when the board looks at the colors, they instantly understand the scale of the threat based on rules they already know. Let us recap the core takeaways from this session. We explored the robust structure of an artificial intelligence audit report, noting that it requires deep methodology sections covering data integrity, model performance metrics like the F1 score and system lifecycle testing. We discussed how internal auditors can act as invaluable internal consultants to guide artificial intelligence development safely, provided they never cross the line into designing the actual controls. Finally, we highlighted the power of dashboards and heat maps to translate complex algorithmic risks into instant readable insights for executive leadership. All the important topics, terminology, and risk concepts from this session are covered in the multiple choice questions on RooCloud.com. You should ideally solve the chapter-wise questions to reinforce your learning and test your understanding of these reporting structures before moving on to the next session. Keep up the great work, and I will see you in the next module.